Okay. All right. So the process here, using the classical approach, we'll be given a level of significance alpha, or we'll determine what we want to use for ourselves. And if making a type 1 error is extremely serious, then we want to shrink alpha for, like, if you were talking about something like dependability of a jet engine plane or something, then maybe 0.05 is not small enough. You need to really make sure that and get a big sample size. Okay, so what we do is we'll calculate the critical value. Here's the test statistic that we're comparing. So we'll call it Z0 because it comes from table 5. So we're going to take our sample statistic, subtract the accepted value, and divide by the square root of this part. So notice that n comes into play. So this is just a direct calculation of this test statistic called Z0. And here's what's happening. If my alpha is being used in the context of a two-tailed test, then I split it to the left side and the right side, because I basically split that area up on both sides. So I'd have to take the Z alpha over 2 and the opposite of Z alpha over 2 and Z alpha over 2. If it's strictly a left-tailed test, then I just go with negative Z alpha. I don't have to split alpha. And if it's strictly right-tailed, I take the error to the right of Z alpha. And then once I get that value, this is basically what the picture is indicating. So if I take my test statistic and I determine that it's below this value, it's that many standard deviations to the left of the mean, well then that's just ridiculous for a sample that was randomly obtained to be that many standard deviations to the left of the mean if it's below negative Z alpha, in this case for two-tailed negative Z alpha over 2. So since a two-tailed test could go on either side, we have to test two conditions. Z0 is less than negative Z alpha over 2, or if it was greater, Z0 is greater than Z alpha over 2. Now obviously if Z0 is negative, it's probably not necessary to test whether it's greater than, because this is a positive number. For the left-tailed test, we're just looking to see if Z0 comes in below negative Z alpha, standard deviations away from the mean, and right-tailed positive Z alpha. And then we'll state a conclusion. If these are true, here's what we do. We reject the null hypothesis. If they're false, then there's not evidence at that level of significance. So alpha determines the level of significance. So if alpha is equal to 0.05, the level of significance is 0.95. So that same relationship between alpha and level of significance as we had when we were doing confidence intervals. All right, so let's look at a situation and resolve it here. All right, so we're talking about eating together. In December of 2001, 38%, so I'm going to highlight things that are important. 38% of adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. In a recent poll, 403 of 1122 adults with children under the age of 18 reported that their family ate dinner together 7 nights a week. So the question is, has the proportion of children who eat families with children under the age of 18 who eat dinner together 7 nights a week decreased? So that's another key word right there. Decrease, that's going to imply a left-tailed test. So has it gotten smaller? And they have to give us or somehow we need a level of significance. And so we've got alpha equal 0.05. So let's go ahead and set up our statements. H naught is that P is equal to the status quo that we're testing against. And if we're worried or concerned with whether it's decreased, makes a left-tailed test. Now we think, is it less than this? And we need, if you look back at our formula, we need this P hat from somewhere. We've got P naught, and we've got N. Okay, so we need P hat, which is just the number reporting over the number consulted, N. Okay, so we come up with 0.359, roughly equal to 0.359. Now, obviously that's different from this, but at this level of significance, is it different enough to indicate that it's decreased? That's what we're looking for. Okay, so if we go and go back to our test statistic, we're going to calculate Z naught. So that equals P hat, so the 0.359. This is on that previous slide. Minus P naught, which is the accepted value, so the 0.38. Divide all that by a square root of P naught times 1 minus P naught. Okay, I think we're all comfortable that 1 minus P naught would be 0.62. That's 1 minus 0.38. Divided by N, and that's 1122. Okay, this is all under the radical. Okay. Let me bring up the calculator here. Let's start over. I'm going to do this all in one statement. So we got 0.359 minus 0.38 in our numerator, and we're going to divide that by a square root of 0.38 times 0.62 divided by 1122. Right, so we're going to say it's roughly equal to negative 1.45. Okay, now going back to what kind of test are we doing? Well, this is left-tailed test. So I have to check if Z naught is less than negative Z sub alpha. Okay, so here's my Z naught. And I need to figure out what's negative Z sub alpha. So alpha is equal to 0.05. Okay, so I'm going to go find Z of 0.05. Now remember, this is the Z value whose area to the right is 0.05. That's not what I want. Okay. Okay, hang on one sec. All right, so I've gotten to get the formulas and tables PDF. And I'm finding table 5, Z-score. So if I look through here and try and find 0.05, so there's 0.0505, so negative 1.645. You'll see that's going to be negative 1.645, where Z to the left is 0.05. Now remember, this is Z to the left. So this would be Z to the right would be 1.645. But look at that, it says to use the negative of Z sub alpha. So we're looking to see if negative 1.45 is less than negative 1.645. Well, that's false. So we do not reject the null hypothesis. And then the statement we're going to make is that there is not sufficient evidence at the alpha equals 0.05 level of significance to conclude that the proportion, pretty lengthy here, of families with children or of adults children under 18 is less than 0.3. All right, so that was the formal official hypothesis test procedure. Okay, I want to get you quick a look at the other approach we talked about. So the test statistic that we're looking at here, we calculate the same way, but we use a p-value. And the p-value is just the probability. In our case, since it's a left-tailed test, it's the probability that z is less than z naught. So it's just the area to the left of z naught. Okay, so our z naught was negative 1.45. So I'm going to consult table 5 again. And negative 1.45 is 0.0735. Okay, and if the p-value so if 0.0735 is less than alpha, well, remember alpha was 0.05. Then we reject H naught. Well, we already saw in the last method that we do not reject H naught, and that's true here as well because 0.0735 is not less than, this is false. So we'll come to the same conclusion. All right, so either of those methods are valid. They're essentially doing the same thing. And then there is a little blurb in here if you want to exercise the calculator's option for doing a hypothesis test on the proportion. Just go through these steps. Okay, before we close up shop here, let me just indicate that what you do, you're going to have a slightly different path if you're doing a two-tailed test or a right-tailed test. So what's going to change, you're still going to get the test stat the same way, but what's going to change is the comparison that you're going to make. And if it's two-tailed, you'll have to do two tests, and you don't use alpha, you use this alpha over 2. Okay. All right, so I'm going to go ahead and leave it there for today, and then Wednesday, like I said, I'll get you more of a summary of all 3 different types of tests for all 3 parameters, but between now and then, we're just going to focus on doing having you do a few of these tests of proportions. So I'll probably sneak a two-tailed in there just so you see the difference in something. Any questions or thoughts about this?